record. Okay, now we're recording. Now, in this assignment, right, in page, let me see, the page is page 4. I'm going to solve this one. So, like a review from yesterday, cosine of the arc sine of 5/13, right? So we have to solve this problem. What is the value of the cosine of the arc sine of this one? So what is this value? Okay, remember the procedure. Number one, draw a right triangle, okay? You draw a right triangle, you the angle, and then you see that you have to find the cosine. Well, this is going to be cosine of the angle, okay? Is what we have to find. What is the cosine of this triangle? Okay, why I'm doing this? Because I'm going to match this with this triangle. Okay, so if I match the cosine with the cosine, I match the theta of the angle with the arc sine. So theta is the arc sine of 5/13, correct? So I'm matching this expression for this triangle with the one I received. Okay, now I'm going to use the inverse functions. What is the inverse of the arc sine? The sine. So I take sine both sides, sine of the arc sine of 5/13, and I know that the inverse is canceled. Okay, so what I find is the sine of the angle is 5/13. So these two cancel and I get this argument. Now I have to remember something. What is the definition of the sine? The sine is opposite over hypotenuse, correct? Okay, so I'm going to use this information. The opposite length is 5, okay, 5. And the hypotenuse is 13, okay, 13. Now I'm going to use middle school math. C squared equals A squared plus B squared. Pythagorean theorem, correct? So what I have here is, okay, 13 squared, that's the C, is A squared plus 5 squared. So I solve A equals the square root of 13 squared minus 5 squared. 169 minus 25 is 144, correct? And the square root of 144 is 12. So I discovered that this side is 12, correct? So I have all the information of my triangle. So now it's easy to do this evaluation. So I need the cosine. Okay, cosine of theta is, okay, what is the definition of cosine? Well, cosine is adjacent over hypotenuse. The adjacent length is 12. The hypotenuse is 13. So this is the answer I'm looking for. But I didn't receive this one. I received this monster. Well, like the theta is this thing right here. The only I have to do is write my answer with the expression I receive. This is my answer. All the problems are going to be solved in the same way, okay? So this is very repetitive, very boring, okay? So again, right triangle trigonometry, geometry, algebra 2, pre-calculus, pre-AP. Definition of the cosine and the trigonometric ratios, that is geometry, pre-calc, algebra 2. Pythagorean theorem, middle school math, no problem. Then the only we have to do from pre-calculus is this, that if you have the arc sine, theta equals the arc sine, the sine of theta is this one here inside. Then you define again your trigonometric ratio, you determine in your triangle the values of the lengths of the sides, and then you use the definition for the function you want to know. This one, adjacent over hypotenuse, you write it, and then you write the final answer. So it's very simple, not a big deal. Now, let me just do now, right? Let me just do now the problem with variables. So this is a review of what we did yesterday, but now we're going to do something more difficult, pre-AP really. But it's easy, it's just scary. So let me just share right here the screen again. This one right here. So this is the problem I just solved. This is what we are going to do now. Now you don't have numbers, you have variables. This is, oh my God. No, don't worry. The x is a number, the 2x is a number. Anything I'm going to have here, right, are going to be numbers, correct? So don't worry about it. So let's begin with this one. So I have, to evaluate the cotangent of the arctangent of x, correct? What kind of monster is going to be that one? It's okay, here is this, okay? Well, again, the procedure is the same. You draw your triangle, okay? A right triangle, you identify the theta, the right angle, opposite, hypotenuse, adjacent. Okay, now, this is the cotangent, so you are going to find the cotangent of theta, right? It's what you are going to find using your triangle. Now, if you match these two expressions, then theta has to be the arctangent of x, correct? Now, if we use the inverse function, if theta is the arctangent of x, then the tangent of theta is x. This is what is. Okay, now, I have to recall the definition of the tangent. Tangent is opposite over adjacent, correct? Okay, now I'm going to match this expression with this one. Okay, I have x, but the x is a single number, and I have here a fraction. Well, remember your middle school math. Every number over 1 is a fraction, correct? So, x over 1 is opposite over adjacent. So I'm going to match. The length of the opposite is x, okay? I'm going to write that one. The opposite is x, so I put here an x. The adjacent is 1. I put a 1 in the adjacent side. Then I have to use again the Pythagorean theorem. C squared equals a squared plus b squared. So c squared, that is this side, is going to be 1 squared plus x squared. And because I don't want the square, I have to find the hypotenuse having the square root. Perform, correct? So I have 1 plus x squared. So this side is 1 plus x squared. So you see, I'm doing exactly the same as with the numbers, except that, well, now I have, right? I have variables, but it's the same. This square plus this square is this one. And if you do the Pythagorean theorem, these sides are very, very consistent. Okay, now I'm going to solve my problem. Cotangent of the angle. Okay, the cotangent is the adjacent over the opposite, correct? Says, well, in this case, it's going to be very simple. What is the adjacent? The adjacent is 1. So I'm going to put here a 1. What is the opposite? X. So the cotangent of the angle is 1 over x. But I don't have theta in my problem. I have the arctangent. So I have to write then cotangent of the arctangent of x is 1 over x. And that's my solution. Okay? You see, not a big deal. It's very, very the same procedure. Okay? Very, very much the same procedure. Okay. Something here that is mysterious, scary, crazy, non-understandable. It's the same. I have been repeating the whole week the same thing. Okay? So again, problem that is difficult, scary, okay. This is a cotangent, a ratio, so I draw my right triangle. Then I'm going, in this right triangle, find cotangent of the angle. Well, the angle has to be this thing in the parentheses, this. Then I just use the inverse function. Tangent of theta is this, because theta is the arctangent of x. And then I remember what is the ratio, the definition of the trigonometric ratio tangent, opposite adjacent. If I don't have a denominator, I put 1. You can put always a denominator, 1. Then opposite of the adjacent match 1 to 1. So this is the opposite, this is the adjacent. I write them here. And then using the Pythagorean theorem, I find the missing side. Once I have the missing side, I complete my information. What is the cotangent? Adjacent, opposite. Well, adjacent divided by opposite is this. So my solution of my original problem is this. Pretty much the same. Okay. Okay, what problem we're going to do next? Let me just put it right here. Okay. Let's just do this one, right? Cosine of arcsine. Okay. Here is the problem. We are going to find the cosine of the arcsine of 2x. Well, right triangle, angle, and then this is the cosine, so we have to match cosine theta. This is what I have to find in my triangle. Okay, who's theta? Theta is the arc sine of 2x, because this has to match this one, so theta has to be this one. Then I'm going to use the inverse. Who's the inverse of the arc sine? The sine. Sine of theta is 2x, correct? Now, because this is a ratio, let me just take 2x over 1, right? Why? Because I'm going to use the definition of the sine. Opposite over hypotenuse, correct? Now, I know now with this definition that the opposite length is 2x, and the hypotenuse is 1. Now, I need to find this side. Oh, Pythagorean theorem, c squared equals a squared plus b squared. Now I'm going to put the information I have. This is the hypotenuse, so it's 1a plus 2x squared, right? This squared plus this squared equals 1. 1 squared is 1. Then I'm going to solve. A squared is 1 minus 4x squared. You square the 2, you square the x, you have that one. And then I don't need the square, I need the square root, so a 1 minus 4x squared, correct? So I found the value of this adjacent side, so I'm going to put the square root 1 minus 4x squared. Okay, there is. Now, with these values, I'm going to find the cosine. Cosine of the angle is defined as adjacent over hypotenuse, correct? Okay, who's the adjacent? Oh, the adjacent is this square root I found. So this is going to be a square root of 1 minus 4x. Who's the hypotenuse? 1. Okay, there is. I found the value of the cosine. So the answer of my problem, so I have to return the theta. So it's cosine of the arc sine of 2x is a square root of 1 minus 4x. Because this divided by 1 is the same thing, so I don't put the fraction, so I just put the number. And that's the answer I'm looking for. So pretty much the same thing, same business. Okay? Let's do one more only. All of them are going to be the same, so I don't want to repeat too much. So let me just select one. Oh, not this one. Let me just select one of this one. Tangent on problem number 4 in the last page. It's page 6. Cosecant of arc tangent. Which one? Let me just do this one. This is fine. All of them are the same. So I have tangent of arc cosine of x over 3 is my question. Right there. Okay, that's the problem I have solved. Okay, right triangle again. Theta. And then, well, tangent is the function I have to solve, so I have to find tangent of theta in this triangle. Okay, who's theta? Okay, theta is the arc cosine of x over 3. I'm going to use the inverse, so the inverse is cosine of theta equals x over 3. So everybody understand this one, there is not going to be a problem. Okay, well, definition of cosine. Adjacent over hypotenuse. So I match who's who. Hypotenuse length is 3. So I put a 3 right here. Adjacent length is x. So this is x. This is the adjacent. So I need to find the opposite. Okay. C squared equals a squared plus b squared. So it's 3 squared equals x squared plus b squared, right? This is b. And then I solve for b. B squared equals 9 minus x squared. Then the only I have to do is a square root. 9 minus x squared, correct? So this side is going to be a square root of 9 minus x squared. Okay, now I need to find the tangent. Okay, tangent is opposite over adjacent. Okay, well, watching my triangle, who's the opposite? The opposite is the square root of 9 minus x squared. Who's the adjacent? X squared, x, so I put x, correct? So what is going to be the solution of my problem? The tangent of arc cosine of x over 3 is the square root of 9 minus x squared divided by x. That's my answer. Okay. So no problems, no question, it's very simple. So I'm expecting this homework by Saturday, but I guess you can finish that one this afternoon. So you can submit tomorrow, is fine. So Friday, Saturday, no problem. I am sure that this homework is going to be 100, quite sure. So next week, no, tomorrow possibly I'm going to begin with something new. But I'm going to remind you, or send you a text with remind, if tomorrow I give you something or give you the day to finish the homework. It's up to you. Let me see, Alex Gomez. Okay, Alex. Okay, welcome to the goodbye. Pretty much I'm going to stop right here because I don't see really.
It's boring and repetitive.
Yeah, it's boring because it's exactly the same. Okay, remember that if you want to see this again, I'm going to save this video and upload it in the YouTube channel so you can check any of the problems again. And that's it. Okay, chat.
Hi, Francisco. Stop.
Hi, Tony.
Chat, Antonio Zamora, everyone. Hi, Francisco. Okay, good. Okay, very good.
You could just unmute. Jeez.
Okay, let me just stop the